Okay, so this is lesson 12.3, writing equations from tables. You should have taken notes in your notebook yesterday. So if you haven't done that yet, you need to go back and you need to take those notes using the Edpuzzle video from Tuesday, and then you can complete Wednesday's work. So the essential question is, how can you use an equation to show a relationship between two variables? And by the way, I'm on page 347. Sorry about that. Again, page 347. All right, so writing an equation to represent real-world relationships. So we talked about in our notes yesterday how when we're given data sets in a table, they form relationships. One thing depends on another thing, okay? So using that information, we can write equations. So let's work through this first activity. It says the table shows how much Armand earns for walking 1, 2, or 3 dogs. You're going to use the table to determine how much Armand earns per dog, and then write an equation that models the relationship between the number of dogs walked and the earnings. You're going to use your equation to complete the table. So see how there's things missing here? Once we figure out what the rule is over here, what the relationship is between these numbers, then we can apply that same relationship over here and we can come up with the answers. You need to always remember this is your independent variable and this is your dependent variable. Okay, so the number of dogs that he walks will change how much money he earns, right? So if we look at these numbers from 1 to 8, 2 to 16, 3 to 24, I always like to start here. What are my options? Well, I could add 7 or I could multiply by 8 to go from 1 to 8. If I add 7 here, that only gets me 9. If I multiply by 8, that gets me 16. So it looks like multiplying by 8 works. And if you notice this box over here, it says for 1 dog, Armand earns 1 times 8, which equals $8. For 2 dogs, he earns 2 times 8, which is $16, which is what we just figured out. So for each column, compare the number of dogs walked and earnings, and what is the pattern? The pattern is going to be is for each dog, Armand earns another $8. We deleted it. It's gone. So part B says, based on the pattern, Armand earns blank for each dog he walks. Well, if you're multiplying by 8 each time, then he's earning $8 for each dog. Okay, now they want us to write an equation that relates the number of dogs, so this is our X value, okay, that he walks to the amount he earns. This is the Y value, all right, his walking and his earning. So we're going to always say Y, okay. They're giving you letters here to use, D and E, but we're going to use X and Y because we're not going to confuse ourselves. So Y, the amount he earns, equals how many dogs he walks times the number 8. So they want us to use our equation now to complete the table for 5, 10, and 20 walk dogs. Okay, so for 5, we would do 5 times 8, and that would be 40. So he's going to make $40 for 5 dogs. If I do 8 times 10, he's going to make $80 for dogs. 20 dogs he walks, he gets $160. Okay, so Armand's earnings depend upon how many dogs he walks. The more dogs he walks, the more money he gets. Okay, if Armand changed the amount earned per dog to $11, what equation could you write to model the relationship between the number of dogs walked and the earnings? So what's changing? The amount per dog. Well, up here, the amount per dog was $8, right? So we're going to use this same equation, and we're going to increase it by 11. Easy enough? Okay, let's turn the page. Move my camera here, sorry. On page 348, It says writing an equation based on a table. It says the relationship between two variables where one variable depends on the other can be represented in a table or by an equation. An equation represents or expresses the dependent variable in terms of the independent variable. When there are no real-world situations, we usually say x is the independent variable, and y is the dependent variable. The variable of y depends on the value of x. It sounds like a different language, right? But all they're saying is talking about the relationships that are happening here. So it says write an equation that expresses y in terms of x. So y in terms of what's happening to x. Is it being multiplied by something? Is it being added to something? So when you're looking at this first one, you're going from 1 to a half. And here we're going from 2 to 1, and 3 to a half, and 4 to 2. So we're going from something big to something small. And if you go back to our equations, and when we were writing equations, when you go from something big to small, you're either dividing or you're subtracting, right? So if you're going from big to small, you divide or subtract. Generally speaking. Not always. Sometimes it's 2 steps, but most of the time you're going to do that. So step 1 says compare the x and y values to find the pattern. Here, each y value is half of the corresponding x value. So we're taking half of 1. Here's half of 2. Here's half of 3, and half of 4, and so on and so forth. So we would write that expression as y equals x times a half, or 1/2 x. You could do it with decimals too. It doesn't matter. It means the same thing. But this is going to be, you could also say y equals x divided by 2, because that's what this means. Okay, so that all of those would be considered right answers. So for part B, you're going from 2 to 5, 4 to 7, 6 to 9. We're going from something small to something bigger. Okay, so we're comparing them and we're looking, and each value, y value, is 3 more than the corresponding x value. So if we add 3 each time to x, we're getting what's in the y box. So the equation here is y equals x plus 3. Okay, so we're going to come down here and we're going to do numbers 2, 3, 4, and 5 together. Okay, so number 2, we're looking at it. We're going from 12 to 10, 11 to 9, 10 to 8. So each time here, we're saying y equals x minus 2, right? 12 minus 2 would be 10. 11 minus 2 would be 9. Okay. I want you to look at numbers 3, 4, and 5, and I want you to figure those out. Look at the relationships. What would the equation look like that you would write down? And I want you to type your answer in the screen. Okay, here for number 3, for each one of these, the easiest thing to do is kind of figure out what's going on here for the smallest one. And this would be 10 times 2.5 to get to 25. So what this is going to be is y equals x times 2.5. And if you do 12 times 2.5, we get 30. And if you do 14 times 2.5, we get 35. That one was probably a little more tricky. Okay, for number 4, you're going to have y equals, and then what's happening each time here? Well, each time it looks like for x, we're adding 5. It gets 5 more each time. Okay, and then here, what are we doing here? Well, we're doing y equals 2 times x. So you can also write this y equals x times 2. They mean the same thing. Okay, you can swap them around because it's multiplication. All right, so you're looking at those relationships and developing equations based on those relationships. So the next part of this on page 349, sorry for moving that around on you. Okay, it says use the table to solve equations to solve problems. So it says you know that the donation amount, actually let's start up here, a certain percent of the sale price of paintings at an art gallery will be donated to charity. The donation will be $50 if a painting sells for $200. The donation will be $75 if the painting sells for $300. They want you to find the amount of the donation if the painting sells for $1,200. So there's a relationship here. For a painting that sells for $200, someone's getting $50. And when they sell it for $300, they're going to get $75. So there's a pattern here we need to find and then apply it to the $1,200. Okay? So you know the donation amount when the sale price of a painting is $200, $300, and you need to find the donation amount if the painting sells for $200. That's what we just said, right? So you need to make a table with this information. So this is not something we do in our head. We have to make a table, okay? So they started making the table for us, and we plunk in the information we know. If we have something that sells for $200, then the donation is going to be $50. If we have a sale price of $300, then the donation is $75. So they broke this down into ratios to find the percents. Okay, so they did 50 out of 200. What's that percentage? Well, that's 25%. Okay, and they did the same thing over here. They said, what's the percentage? Well, it's 25%. So no matter what, every time we're taking 25% of the sale price and donating that to the cause. So they want us to write an equation, and they want you to let P to represent the sale price of the painting and let D represent the donation amount to the charity. So in both cases, these both came out as being 25% of the total cost. So when we multiply a percent, you have to put it in the form of a decimal. That's why this is 0.25 and not just 25. All right, so 0.25 times P will help us find our final answer, okay, for the 1,200. So then it goes through here and it says find the donation amount when the sale price is $1,200. Well, this is the sale price, so this is P. So we're going to plug this in for P right here. So we're going to do a substitution. We're going to multiply 0.25 times 1,200, and we get 300. So when the sale price is 1,200, the donation is going to be 300. So once again, you're just looking for the relationship, what's happening each time, and then you're applying that to the whole chart. Okay? Well, let's go ahead and turn the page for a minute. And let's try this one up here, number 6. So number 6 says, when Ryan is 10, his brother Kyle is 15. When Ryan is 16, Kyle will be 21. When Ryan is 21, Kyle will be 26. They want us to write and solve an equation to find Kyle's age when Ryan is 52. Tell what the variables will represent. So notice to keep putting it in the same order. Ryan, then Kyle. So let's make the top one Ryan and the bottom one Kyle. We're going to maintain the order. When Ryan is 10, Kyle is 15. When Ryan is 16, Kyle will be 21. When Ryan turns 21, Kyle will be 26. So all we're doing is plugging in the information that they've given us. Now they want us to find the equation. So what's happening in this relationship here? And then I'm going to add another box right here. They want us to find how old will Kyle be when Ryan's 52. And we can find this, okay, using the equation. So what's happening to Kyle's age each time? They're taking Ryan's age, which is our x, and each time, what are we doing? Each time we're adding 5. So my equation is y equals x plus 5. And if I know that, then I can apply that to this portion of the table and say, all right, when Ryan is 52, Kyle is going to be 5 years above that, which would be 57. So in the end, I can say Kyle will be 57 years old. It's as easy as that. Okay. So now the next thing I want you to do is come down and you're going to work on the guided practice portion down here. Okay. So they want you to write an equation to express y in terms of x. That's the equation. Y equals x what? What's happening every time here? So look at the relationships. Can I subtract something? Can I add something? This is going from big to small. And each time here, we're happening to be taking x and subtracting 4. Okay, so you're going to try this page, and then I want you to come back and I want you to check your answers. So press pause, go do your work, and then come back and see how you did. Okay, for the rest of this, now that you've gone through and done this, you should be here checking this. Don't just copy. Make sure you're checking it. So for number 2, we're going through here 0 to 0, 1 to 4, 2 to 8, 3 to 12. What's happening here? Hopefully you determined that this is multiplying x times 4, so you can write it y equals 4x. You could also write it x times 4. They mean the same thing, okay? Just make sure that this is distinctly a multiplication. Number 3, 4 to 7, 6 to 9, 8 to 3. This is going to be y equals x plus 3. And number 4, you're going down from a big number to something small. So what am I subtracting? Am I dividing? This one's going to be y equals x divided by 6. You could also write this y equals x divided by 6. It can't be 6 divided by x. That would be wrong. So you have to make sure you have the order part correct here. Number 5, it says Jameson downloaded 1 digital song for $1.35, 2 digital songs for $2.70, and 5 for $6.75. Write and solve an equation to find the cost downloaded for 25 songs. So we want to put a box out here for 25. Whenever you have 1 and then the number, this generally is where you're going to find your rule. So in this case, we could do 1 times $1.35 to get $1.35. And if I do 2 times $1.35 and I do that math, it does come out to $2.70. So that's working. So then I do the same thing with 5 and it comes out to $6.75. So then if I do it with 10, it should come out to $13.50, right? So the number of songs is going to be N. We'll make that letter there. And the cost is C. So our equation is C equals the number of songs times $1.35. All right. So for 25 songs, we would take $1.35, multiply it times 25. And you should get $33.75. Okay. All right. So hopefully that's making more sense to you and it's not quite so scary to do. Your job now is going to be to do numbers 7, 8, 9, 10, 11 on page 351. And I think we'll call that good for the day. I gave you some little tips here to kind of look at where they're talking about explain what it means when you want to put y in terms of x. What does that mean? You need to go back and look in your notes and you need to go back and look at these pages that we just did to find that explanation. Number 8, the length of a rectangle is 2 inches more than twice its width. So this one is 2 steps. I'm going to tell you that right now. When you write this equation, it's 2 steps. So you're going to like multiply something and then add, or multiply something and then subtract, depending on what these words are telling you to do. Okay? 9 and 10, you're going to have to do a couple of different things. They want to know, what is the pattern you see? Okay, and how is this pattern used to write the equation that represents? So we want to know, what's the pattern? And write the equation. So 2 things here. And number 10, it says a student modeled the relationship in the table with the equation x equals 4y. There is something clearly wrong there. Explain this student's error and then write an equation that correctly models this relationship. So what I would do is I would first ignore this for a moment, and I would come look here and write my equation based on what you've learned, and then look at how they wrote it and see what went wrong and then explain it. For number 11, down on the bottom, you could make a chart. One side could have the hours he works, the other side could have the amount of money that he's making, and you can figure out how many hours he needs to work to make $206.25. All right, when you're done with this, I want a picture of it, please. Send it to me. And if you have any questions, let me know.